Deep beneath the Austrian and Italian Alps, this steel giant is carving a new path through history. But how can engineers stabilize such an enormous void under the weight of miles of mountain? To solve this, we must return to the bottleneck that has challenged travelers for centuries.
The Brenner Pass has always been a vital artery, but its steep gradients limited the speed and volume of cargo.
This corridor is one of the most important in Europe, yet it faced a crushing logistical bottleneck.
Truck traffic alone was pushing the environment and infrastructure to a breaking point every single day.
Expanding surface roads was impossible due to the local communities and protected alpine wilderness.
The radical solution was to go beneath the mountains, creating a base tunnel with a nearly flat profile. This wasn't just a tunnel. It was a 64-kilometer-long engineering marathon spanning 2 nations.
The Alps hold massive water reserves, a hidden threat that could flood any underground excavation. The
engineers had to map the shifting rock formations to predict the crushing pressure they would face.
Preparation required years of site work before the first machine could even touch the mountain face.
Every support beam, every ventilation shaft, and every haul road was a critical piece of the puzzle. The sheer volume of concrete segments needed meant building dedicated factories directly adjacent to the portals.
High-strength concrete, formulated for extreme alpine conditions, flows into these custom-designed molds around the clock.
With the staging complete, the mission to pierce the mountain officially began in earnest.
Initial stages used controlled drilling and blasting, a slow and precise dance with the mountain.
But as they dove deeper, the geological unpredictability demanded a more robust solution. Enter the TBM, a rolling steel factory designed to chew through rock while sealing the tunnel walls.
These discs exert immense pressure, fracturing the rock ahead so the conveyor can carry it away.
Operating this machine requires constant vigilance. The margin for error is measured in mere millimeters. As it moves, the machine erects the tunnel lining, essentially building the shell from the inside out.
It is a perfectly choreographed sequence that must continue 24 hours a day without interruption.
Real-time data feeds sensors embedded in the mountain, tracking every shift in stress and water pressure. When water strikes, engineers must freeze the ground or drain the rock before it turns into a disaster.
Logistics for moving millions of cubic meters of spoil out of the tunnels is a challenge in itself. The tunnel network is essentially an underground city, complete with its own transport and support systems. The biggest fear is hitting a fault zone, an area where the rock is essentially crushed and unstable.
When the mountain pushes back, the structural design must be flexible enough to absorb the energy.
Steel reinforcement creates the internal skeleton that keeps these enormous pressures from crushing the tunnel.
Spraying high-strength shotcrete immediately stabilizes the rock face before permanent liners are installed.
Building junctions where multiple tunnels meet is a complex geometry puzzle of interlocking structures.
Precision is absolute. If these tunnels don't meet exactly, billions in investment would be wasted. At the heart of the TBM is a massive bearing that rotates the entire weight of the cutter head. Life support systems, power lines, and emergency ventilation must be integrated into every single meter of progress.
Ventilation is not a luxury. It's the lifeline that keeps the air breathable for the thousands working underground.
Even getting fuel and spare parts up to these portals is a logistics triumph against the mountains.
While the world sleeps, The tunnel continues its slow, steady crawl toward the heart of the Alps.
Enter the TBM, a rolling steel factory designed to chew through rock while sealing the tunnel walls.
Engineers scramble to reinforce the sector, reinforcing the arch with extra steel to prevent collapse.
This is the reality of the Brenner, a fight against a mountain that refuses to stay still.
Chemical grouting fills the voids, turning loose rock into solid ground before they move ahead.
Collaboration across borders is constant, with teams in Austria and Italy sharing real-time excavation results.
The project isn't just one tunnel, but a complex web of service and emergency shafts that ensure safety. This steel shield is all that separates the crew from tons of unstable rock and water. Even maintenance is an engineering feat, requiring cranes large enough to handle locomotive-sized components.
Every meter gained is a testament to the thousands of people working in the dark. Progress is steady, but the remaining stretch holds the most difficult geology of the entire route.
Technical hitches are inevitable, but they are met with calculated, calm problem-solving. Swapping these cutters requires precise timing and heavy-duty skill in extreme working conditions.
The machine's torque is immense, designed to overcome the friction of the mountain's shifting pressure.
The surveying teams ensure that everything aligns with the long-term design grid of European rail. The TBM continues to advance, a machine made for one purpose: to master the mountain. This constant flow of debris is the visible record of the tunnel's slow growth.
Back on the surface, geologists monitor the mountain's behavior to keep the tunnelers safe below.
We are now nearing a milestone that defines the success of this monumental engineering project.
The human element remains the true driver of this project, despite the robots. It's all human skill.
The restart is always the most critical moment. Everything must sync perfectly. Returning to the front, we see the culmination of years of preparation and engineering precision. With each centimeter, the barrier that once held back Europe's traffic is being dismantled. The progress is slow, but the victory is tangible in every finished tunnel segment.
When these sections meet, the true achievement of this base tunnel will finally stand revealed. Faster, heavier, and more efficient trains will soon replace the struggle of the old pass.
This is the power of engineering, solving impossible problems by breaking them down into small, solvable steps. At 64 kilometers, it will stand as one of the longest land-based tunnel systems in existence.
The time savings will be dramatic, shifting millions of tons of freight from road to rail. It is the final bridge between Northern and Southern Europe, a vital connection in a changing world.
The people who built this have left an indelible mark on the landscape of history. The Brenner Base Tunnel is more than just infrastructure. It is a monument to human ingenuity.
Construction remains active, with the final breakthroughs scheduled as the project moves closer to its goal. There is still work to be done, as the final phases of testing and installation await their turn.
Somewhere else in the world, engineers are already planning a new feat, waiting for the next impossible problem to solve.